All right, guys, welcome back to part 2 of our Unit 3 review video. For you, that could have been a couple seconds. For me, it was like an agonizing hour waiting for the video to upload. But here we go. We're back at it. So number 8, if you want to get started on that, click the pause button. All right, welcome back. So for reaction type number 8, we can tell this is a decomposition reaction because we only have one reactant, right? There's nothing else for it to react with. It must be breaking down. So because it's a decomposition reaction, we want to turn to our predicting products cheat sheet, right? The one that has our comp and decomp reactions. Alrighty, so I see that our question is Na, which is sodium chlorate. So a sodium chlorate. So we're going to be looking for our decomposition reaction that has the word chlorate in it, and that would be decomposition reaction number 3. A metallic chlorate gets you a metallic chloride plus O2 gas. Okay, so this is a decomposition 3 reaction. And our products should be sodium chloride, NaCl, plus O2 gas. Alrighty. And if we look at these to get them balanced, I see I have one sodium, one chlorine, 3 oxygens, and 2 oxygens. So I want to get them both to 6. Which means I need to correct my sodiums and chlorides by putting a 2 in front of the NaCl. Alrighty. All right, we're ready to start number 9. So if you want to click the pause button and do number 9, I will wait for you. Welcome back. All right, so for number 9, we have aluminum oxide plus water. Right. Both of these are compounds, right? But water is not an ionic compound. A lot of times if you see plus water, you should automatically be thinking of a composition reaction. All right, so what type of composition reaction is this? Well, I have a metal, right, aluminum. So I have a metallic oxide plus water. My metallic oxide plus water is a composition 4 reaction, and my product will be a metallic hydroxide. So my metal is going to stay the same, right? I will go from having aluminum oxide plus water to having aluminum hydroxide. All right, and then we'll need to convert this all into our formulas. So aluminum oxide would be Al2O3 plus water, H2O, produces aluminum hydroxide, which would be AlOH3, right? Because aluminum has a positive 3 charge, hydroxide negative 1, right? And hydroxide being polyatomic, we need the parentheses to show if we have more than one polyatomic ion in this compound. All right, so to balance this, I'm going to need, I have 2 aluminums and 1 aluminum here, and I have 4 oxygens and 3. So let's balance out my aluminums first. Okay, we want to try to save the hydrogens and oxygens for last if we can. So this now gets me to 6 oxygens and 6 hydrogens. So we're going to need to get this to 6 hydrogens. Okay, so putting the 3 there gets me to 3 oxygen for a total of 6, and I have 6 here. We are balanced and good to go. All right, so that's the first page. I have a couple more on the second page, or one more, and then a couple questions for you. All right, so, and I think we should do another combustion reaction at the end of this too. There's only one combustion example. So we have number 10. Why don't you pause the video for a second, answer this out on your own. Welcome back. Hopefully you recognize this as a double replacement reaction, right? Because we had 2 aqueous ionic compounds, and our products should be calcium carbonate and sodium chloride. So we have calcium carbonate plus sodium chloride. All right, this being a double replacement reaction, we need to identify the phases of our products. So we want to use our solubility table, right, on our pink sheet, and we want to look up calcium and carbonate. So if I look up calcium and I look up carbonate, calcium right here and carbonate, I get an I, which means I have an insoluble compound or a solid. So calcium carbonate will get our S, and we look up sodium chloride. Right, we should all probably know this one by now, right? But sodium and chloride together is going to be an S, which means I am aqueous. Right, so sodium chloride is aqueous. All right, but we're not done. We need to put this into a balanced chemical equation. All right, so calcium chloride would be CaCl2, and it is aqueous. Right, it is very important for these double replacement reactions that you have all of your phases written in. Sodium carbonate would be Na2CO3. Again, this is aqueous. And it produces calcium carbonate, CaCO3, solid, plus sodium chloride, NaCl, aqueous. All right. Now we need a balance. So on the reactant side, I see I have 2 sodiums and 2 chlorines. So I need to put a 2 in front of my sodium chloride. I have 1 calcium, 1 calcium. I have 1 carbon, 1 carbon. I have 3 oxygens and 3 oxygens. So we are balanced and ready to go. All right. So let's do, before we hop into 11 and 12, let's do an example of a, I'll leave this here for a second, of a combustion reaction. Okay, so let's try. Right, so we know this is a combustion reaction, so you don't need to identify it. But I'll give you the products. Right, C9H20 plus O2. All right, C9H20 plus O2. Take a second, pause the video. Welcome back. So when we do a combustion reaction, our products are always water, H2O, plus carbon dioxide, CO2. In order to balance this, I have 9 carbons on this side. I need to do 9 on the other. I have 20 hydrogens on the left. I need to get to 20 on the right, so I can put a 10 there. And this gets me to 10 oxygens plus 18 for a total of 28. So I can get my oxygens to 28 by putting a 14 in front of the O2. Good, so that was a little bit more practice on a combustion reaction. Let's take a look at 11 and 12. So for number 11, it says, which would be the result of combining hydrochloric acid with magnesium? Right, so if we combine these two, hydrochloric acid would be HCl plus magnesium Mg. Right, so this should look like a single replacement reaction. Right, correct? You see a compound plus an element. We know this is a single replacement reaction. Right, so we need to compare magnesium, which is a metal, with our hydrogen, which is the positive ion in our compound. So we want to use our activity series. Right, this is a single replacement reaction. Compare magnesium with hydrogen in the acid. We have magnesium up top and hydrogen in an acid down below. Right, don't get that confused with hydrogen in water. It's harder to separate a hydrogen from water than it is from an acid. So in this reaction, right, magnesium would end up with a chloride and it would kick the hydrogen out. Now when hydrogen's kicked out, it's kicked out in the form of a gas, right? So what this means is our reaction will bubble. Okay, does that make sense? I probably should have waited to ask that question. I apologize for that. I'll do better on number 12. All right, so for number 12, what should be the result of combining aqueous lead chlorate with barium nitrate? So why don't you pause the video, try to answer number 12 on your own. Right, you might have to write out the formula yourself before you can answer this question. That's okay. All right, so pause the video. Welcome back. So when doing this, I have lead chlorate, which would be PbClO3 2 plus barium nitrate, BaNO3 2. Okay, so we're looking at what our products will be. I don't think I need to continue writing them in formula, but we can write them out. So Actually, I should do both. So let's start here. We have lead nitrate or chlorate. It's aqueous. Plus barium nitrate and our products will be barium chlorate and lead nitrate. That's a 2 in there, 2 Roman numerals. Alrighty, so in order to answer this question, we actually don't need to do the balanced chemical formula. I will do that anyway, just so you can check your work. But we want to look up these two compounds, barium chlorate and lead nitrate, and see what will happen. So we want to use our solubility table since this is a double replacement reaction. So we want to look up barium and chlorate and see what we get. So we have barium here and chlorate, and this tells me it would be aqueous. So barium chlorate is aqueous. Okay, and lead nitrate, so we want to find lead 2 and nitrate, find where they intersect, and that is also soluble, right? It is also aqueous. And in doing a double replacement reaction, if both of our products are aqueous, right, what actually happened was we had no reaction, and RXN is just an abbreviation for reaction. So what would happen? Nothing would happen, right? We just have a bunch of ions floating around in water. All right, so that ends my review video for you. If you have any questions or concerns, please shoot me an email. This is one of our last big grades. The semester is coming to a close. I need you guys to take this seriously if you are serious about passing or doing well in this course, right? We're all in a different scenario here. Some of us have been putting in more effort than others, and right, if you have not been putting in that effort, now is the time, right? You do not want to retake this course, but if that's the situation you put yourself in, right, I'm happy to see you next semester. But that's not what we want to happen. You can succeed at this. It takes a little bit of effort, but you all have the potential to do this. So best of luck. I will see you on Monday or Tuesday. Adios.